if we could use a proper SQL database instead to store all of these key value pairs. Well, in fact, let me go back to VS Code here. And inside of VS Code, let me show you a database file that I prepared in advance. Let me maximize my terminal window. And I've just copied over already a file called froschims.db, which is a database just for these intramural sports. Let me run our old friend SQLite 3 on froschims.db. That puts me inside of the SQLite program. And recall that if I type .schema, I can see what table or tables are inside of this database. Sure enough, there's just one table here called registrants. And it seems that that table has 3 columns. An ID column, which is an integer, presumably the primary key. A name column, which is text that cannot be null. And a sport column that's also text that cannot be null. And sure enough, the primary key of this table is that first column, ID. So if I now take on faith that this table exists, even though at the moment select star from registrants seems to have no rows in it, I think I can write some code to put registrants there. So let me go back to app.py here. And at the top of my file, let's do this. From CS50 import its SQL feature. And then down here, a few lines later, let's go ahead and create a connection to that database via a variable called db. Set it equal to SQL, quote unquote, SQLite : ///. So even though it looks like a URL, you do need the third slash in this case, froschims.db. And recall that from week 7, this is how I'm going to be able, from Python, talk to that SQL database. Let's now scroll down to this registrants variable, which previously I was using to store these key value pairs, and let's just get rid of it altogether, because I don't want to keep storing these registrations in memory. Let's go down further to my register route and get rid of the use of that dictionary, because instead I want to do something now with SQL. In particular, I'm going to do this. db.execute, quote unquote, insert into registrants, maybe 2 things, name, comma, sport. I'm going to let SQLite automatically fill in with auto increment, the ID column therein. The values I want to plug in, though, are these 2, with 2 placeholders, question mark, close quote. And the 2 values I want to plug in for those placeholders in SQL are name and sport, respectively. So here too, I'm using the same terms, placeholder, but in the context of SQL, not in the context of Jinja. The syntax and the purpose is a little bit different, but that's exactly what we explored in week 7 with SQL and Python. Now, after that, I think we're good with the register route. What we do still need to do is get rid of this final use of that dictionary. Previously, I was passing into my registrants route that global dictionary, so I have all of those key value pairs. Now, a SQL table is not all that different from a dictionary if we focus on just 2 of its columns, name and sport. So how can I get at those columns inside of my registrants route? Well, let's create a registrants variable, set it equal to db.execute, and this part's easy. Select name, comma, sport from registrants to select exactly those 2 columns. That's going to hand me back a list of dictionaries, each of which itself represents a name value and a sport value. So if I now change this value from registrants in all caps to registrants lowercase, this is the variable being passed in the template. This is the value thereof. And I think if I go now into registrants.html, I just need to make a tweak whereby now if I'm iterating over those return values from db.execute, I need to be a little more explicit. So instead of iterating over a dictionary as I did before, I'm going to more generally iterate over a registrant in that list of dictionaries. And I'm going to spit out here registrant.name. And down here, I'm going to spit out registrants.sport. And it turns out in some contexts I can use either the square bracket notation or even the dot notation. The dot notation being a little easier to read because there's less syntax. But the reason I can do that is because, again, the registrants variable that I'm passing into this template is itself a list of dictionaries. And each of those dictionaries represents a row from the SQL table. And so if I want to access the name column therein, I can say registrant.name. Or the sport column therein, I can access registrant singular. This was about to be my next typo, registrant.sport. And so now, crossing fingers big time this time, let me go ahead and go back to the form itself. Let me go ahead and register myself for basketball because we cleared the memory when switching to SQL. Let me now go back again and register, say, Yulia, this time for soccer, and register. And now let me manually change my URL to be registrants, big time crossing my finger, and There we have it. David and Yulia, I was as surprised as you as at work this time, but David and Yulia are registered, and more importantly, if I go back to VS Code here, select star from registrants in my database, there are those two rows. Moreover, if I exit out of SQLite and I go into my other terminal and even Control C, and restart Flask with Flask run, and go back to /registrants in my browser and reload, the data is still there. We have made now a full-fledged web application, if ugly, that is actually storing data permanently, full-time, that survives clearing of memory and even reboots of the server. All right, still more to come. Let's go ahead and take a 5-minute break, and when we come back, we'll add lastly, some of the most familiar features that you see in today's actual web applications. See you in 5. All right, so up until now, even though we've been building an application that's very specific to Frosh IMs, it's actually representative of a paradigm when it comes to web programming and software engineering more generally. In fact, up until now, what we've really been implementing is a couple of concepts. One is what we would generally know in software engineering is a controller. So app.py is representative of a type of program that you might call a controller. For exactly that reason, it's controlling everything about your application. It contains the so-called business logic for your application. Meanwhile, though, there is a part of the application that the user sees and interacts with, and that's generally known in some circles as a view. So everything in the templates folder really is a so-called view. But in that most recent example with the Frosh IMs, once we started writing and reading data to and from a database, we introduced a third piece of the puzzle, which is generally known as a model. And model refers to the database or some kind of storage that you're using to read and or write data. And collectively, these three ideas of model and view and controller are generally referred to as MVC, model, view, controller, and it just describes one type of architecture when it comes to implementing a web application or really other types of application, whereby when you sit down to design them, you don't just implement everything in one massive file, which we've kind of been doing throughout much of CS50, but rather you separate concerns. You put all of your templates, aka views, over here. You put all of your model-related code over here, and then you have a controller that's somehow orchestrating between those two concepts. It doesn't change anything we've yet done, but it does slap some industry standard labels on top of them. Speaking of industry, it turns out it's incredibly common on websites, of course, to log into them as your, like your Gmail account, for instance, if you use, or Office 365 or some other email service, or really any website nowadays for which you have a username and password and log in. And indeed, up until now, neither of the applications we wrote, the Hello World application or Frosh IMs, had any notion of individual users. There was no login, which means anyone who sits down at the keyboard could type in some input. What that means similarly is that anyone who's at the keyboard can see all of the information therein, including the form itself, the list of registrations, the confirmation pages, and that might not be ideal because if we really are implementing the idea of those paper-based forms back in the day, well, really only that resident advisor or proctor should have access to the forms once they're submitted. Everyone shouldn't be able to just change their URL to /registrants and be able to see something. Which is to say, if we did want to add the ability to log into a website so as to exercise finer-grained access control so that I can see this, you can see that, we need to somehow add more functionality to these applications, much like Google has added to their own Gmail page. Unfortunately, the way HTTP is designed is that every piece of information that goes between browser and server has to be sent all at once for the browser to know about it. And yet, when the user then clicks on another link, ideally in some cases, the server would like to remember, oh, wait a minute, this is the same user, and I already logged them in before. You don't want to have the user to have to log in every time they click a link or every time they submit a form to prove to you that they are who they claim to be. In other words, you'd like to be able to remember that someone has already logged in. So for instance, in the real world, if you go into a club, an amusement park, or a bar, sometimes they put a little bracelet on you, or sometimes they stamp your hand. And that hand stamp is meant to confirm, if you come and go through the same door, oh, we've already authenticated you. We've already checked who you are so that we don't have to pull out your ID and look at it again. So in fact, I actually have a little hand stamp here. And so if you imagine that here is my hand with no stamp on it being presented to get into some fun amusement park, once I've shown them my ticket or my ID, what they might very well do is, if not a bracelet, put a stamp on my hand like this here smiley face, and so long as I show that to the bouncer or the ticket taker again and again, they will remember that I have already authenticated myself by showing them my ticket or showing them my ID in the past. Now, it turns out that HTTP, funny enough, can implement exactly this same idea, albeit more technically. Recall that when using HTTP, you see a message like this in the browser being sent to the server, for instance. For instance, when you log into Gmail specifically, inside of that virtual envelope goes a post message, followed by slash or some such route, followed by the version number of HTTP, and then maybe some reminder as to what host name is being posted to. Meanwhile, the server hopefully responds, as we saw last week, with HTTP 200, which is a status code meaning OK. But wait a minute, if we have already this mechanism whereby the browser can talk to the server and the server can talk to the browser, could we implement from the server to browser this notion of a hand stamp? Well, we can. We haven't dwelled on these too much, but recall that inside of that virtual envelope, such as one pictured here, is a HTTP header, one or more of those things. And in fact, every time I've pulled up developer tools, there's actually been a whole bunch. This is just a key value pair. So maybe if we could somehow implement this notion of a hand stamp as a key value pair, we could remember that someone has logged in. Moreover, we can remember who has logged in somehow as well. And in fact, the way that HTTP has browsers and servers do that is as follows. When you log into Gmail or really any website, what that server does in its response message to you is, unbeknownst to you really, is it stamps your hand. Specifically, it includes in the virtual envelope among all of those HTTP headers another key value pair, namely set-cookie, and then some value. And while you could somewhat foolishly just put the user's email address, like set-cookie, session equals mailin@harvard.edu. Generally, the value inside of that HTTP header is like a big random value, a big string of text and or numbers that somehow the server keeps track of and remembers that, okay, I gave David this big random number. I gave Yulia this big random number. So we don't all get the exact same smiley face hand stamp. But the next time the user from that same browser clicks a link, submits a form, unbeknownst to you, the browser sends another header in addition to the usual, namely a cookie header. Cookie, and then the exact same string, session equals value, for instance. And session itself is kind of a term of art. Session refers to the concept of maintaining state between the browser and server, even though HTTP by design is really meant to be stateless. Once the browser icon stops spinning, you've gotten all the data you're going to get from the server. But so long as the browser knows that once it receives a cookie, send it back to the server, include it in every subsequent virtual envelope, the server can remember that, oh, I've seen that smiling face before. I've seen that big random number before. That must be David. That must be Yulia. And so it's a very clever way of just reminding the server who you are. And to be clear, the cookie itself could be your email address. Heck, you could even use your password just to constantly remind the server, here's my username, here's my password. Here's my username, here's your password. But that's generally not a good idea, and you should not be doing that nowadays because it's all too easy potentially for the data to get intercepted. And certainly don't send usernames and passwords over the internet more often than you need to, just as a good principle. So with that said, if we have the ability to stamp the user's hand in this way and to remind the user what's there, what you're looking at indeed are cookies. And in fact, this class is so long already, it's a good thing we brought some snacks for today. So these here cookies, these are what cookies actually are. And all of us have probably heard about cookies in the context of the internet for some time, whereby cookies get saved on your computer from the servers that you actually visit. Well, what is a cookie? There's really no academic value to what I'm doing here, but what is a cookie in the context of the web? Well, it is just typically a big random value that's stored on your computer. And it doesn't have to be random. It can be, for instance, your username. It can be your email address. Hopefully it's not your password, but if you've ever checked that box that might remember your email address and auto-populate it, it may very well be the server that's reminding you of that same value. The reason that cookies get kind of a bad rap, though, is that there's a lot of cookies typically being stored on your browser from servers around the world. And a lot of those cookies are used to track you and me. Now, it stands to reason that if I've logged into a website, well, of course, the website's going to be able to track my behavior on that website because I literally told them who I am. But in the world of advertising, for instance, it turns out that even if you're not logged into a website, there are enough unique features to your computer and your browser and the way that you use it that servers can typically plant cookies on your computer, even without your logging in. And even though they don't know that I am David and that is Yulia, they do know that I'm the same user again and again. And they can effectively build a profile of who you are based on all of your clicking behavior. So if you recall last week when I first was demonstrating various features of HTML and the like, I was actually deliberately using incognito mode sometimes because I wanted to start with a fresh slate. And so among the things that incognito or private browsing mode typically does is it gives you a brand new empty cookie jar, so to speak. It clears the browser's memory just for that window that you've opened privately, and it makes sure that you have no cookies by default and you have no other settings by default being sent back and forth to the server, effectively ensuring that you're starting from scratch. But if you're using the same non-incognito or non-private tab again and again and again, you really are accumulating a lot of these cookies. And in fact, if you open up developer tools, you can see under the storage tab or thereabouts in other browsers, all of the key value pairs that servers are storing on your computer. So with that said, let's use cookies, no, not for evil, but for good, and to actually use them to remember that a user has logged into a website. And to do that, we're going to leverage a feature of Flask that is built on top of these cookies known as a session, which is, again, just some form of memory that keeps track of the fact that we have seen some user before. In effect, a session is the technical way to describe something like a shopping cart. Anytime you've bought something online or added something to your shopping cart, you could come back a few minutes, a few hours, a few days later, and depending on how the website is implemented, it can remember what is in your cart thanks to these cookies. Similarly, we can remember that you're logged in via these cookies using this here feature.